Hello all, welcome to my channel. So today we will learn about the difference between autocorrelation and cross correlation. These are the terms related to random process, that is the signal which changes with time. It can be a noise in communication system and it is very important for examination point of view. And first of all, autocorrelation is denoted by Rxx tau and cross correlation is denoted by Rxy tau. So the first point of difference is that autocorrelation is actually we are finding the similarity of signal with itself. That is, we are taking the same signal but there are two times at different times. Okay, so it is given by Rxx t1 t2 is equal to expectation of xt1 multiplied by xt2. That is, we multiply the same signal at two times and then we take the average. On the other hand, cross correlation is between two different signals. So it is given by Rxy t1 comma t2 expectation of xt1 multiplied by yt2. So there are two times definitely like this one t1 and t2, but now we are using two signals x and y. And we know that for wide sense stationary random process, mean is a constant value. Okay, and mean is not dependent on time. So mean is a function of delay only. So Rxx tau is equal to expectation of xt multiplied by xt plus tau, where tau is the delay and it is given by t2 minus t1. So this is the formula when you are given in a question that is a wide sense stationary random process, then you can use this formula expectation of xt plus tau for autocorrelation. We know that autocorrelation is maximum at zero delay. When the delay is zero, that is signal is most similar when the delay is zero, because we are finding the similarity of the signal to itself. So Rxx tau is less than or equal to Rxx 0, because Rxx 0 is the maximum value and it is also the total average power. It is given by expectation of x square t. Okay, and what for cross correlation? It can be maximum, but this is not actually dependent on delay between signals. Okay, so this is not the same because there are two different signals. Second point of difference is that Rxx tau is an even function. Like if you find Rxx tau, it will be equal to Rxx of minus tau. Cross correlation is generally not even, because we cannot say that it will be same at minus tau. But there is a property that Rxy tau is equal to Ryx of minus tau. That is, if you interchange the signals, delay sign changes. And there is one more important property which is mostly used in numerical, that if you perform the Fourier transform of autocorrelation, then you will get the power spectral density. So Rxx tau is given as a Fourier transform of, you can say that Sxx omega is a Fourier transform of this function. So you write the Fourier transform formula here, that Sxx omega is equal to minus infinity to infinity Rxx tau multiplied e to the power minus j omega tau d tau. This is nothing but a formula of Fourier transform. And similarly, the inverse Fourier transform will be the autocorrelation function. Similar here, the Rxy tau, which is a cross correlation function, it is here it is cross spectral density. So the Fourier transform of this gives the cross spectral density. Same formula applies here. Sxy omega is equal to minus infinity to infinity Rxy tau into e to the power minus j omega tau d tau. Rxy tau is equal to 1 by 2 pi minus infinity to infinity xxy omega e to the power j omega tau d omega. So this is the inverse Fourier transform. Okay, now fifth point of difference. Autocorrelation, we know that it is maximum at zero delay, but if signals are orthogonal, then there is a property of cross correlation, that is Rxy 0 will be 0. But the cross correlation at zero delay will be expectation of xt into yt. So these are the general points of comparison between autocorrelation and cross correlation. And if you like this video, please like, share and subscribe my channel. Thank you.